Hey all, welcome back to the lab. In this video, we're going to be talking about C# records and how to use them. So records are thin data types that typically have value-based equality and are immutable. I like using them in most programming languages as I think they help keep data and behavior separate, which often leads to more testable and composable systems. Here we'll walk through using records in C#. And so in C# they're called records. This idea of records and what we're talking about exists in most languages or is possible to achieve in most languages, even if they might not necessarily be called records. But typically records is what this idea is called if you're looking it up. All right, so how to write records in C#. So first, to declare a record, we can use the record keyword. And here we define a simple person record that has a first name and a last name. So public, record, person, and then we give it all of its params, first name and last name. And I'm actually going to switch over to my IDE so that we can get some syntax highlighting here. Okay, so here we are in my editor, and I'm just going to go ahead and run this to show you that this is like real C# code. It's running, and we get an output here, so you know that it runs. And now we'll kind of walk through it. And so I'm using C#'s new like one file running thing, which means that I actually have to put the type declarations at the bottom. So we have that here. And that's exactly what we said, public record person string first name and then last name. And so these are going to be the parameters. These are what's actually going to be on the objects, and these will be immutable. Okay, and so the first thing we want to talk about is how do we actually create these objects? So the way we create them is just like any kind of other object or class in C#. We're going to be just saying new person, and then we pass in the values or the parameters here. These are order-based, which I don't typically like. And so what I would actually prefer when using these is to use keyword-based parameters. The reason being that it's so easy to mess this up, especially if you end up refactoring something, either removing a property or rearranging properties or something like that. And so having, keyword-based names makes sure that we always are only setting the value that we expect to be setting, and we actually get errors if that value no longer makes sense. And so here what I'm doing is I'm creating A, I'm creating A clone, which has the same values as A, and then I'm creating B, which just has different values, and then C just exists here to give you an example of the other constructor type. And so we're going to scroll down here to show you A equals to A clone and A equals to B, and we can see that A equals to A clone actually returns true, and the reason that it returns true is that this is value-based equality, so it's actually looking at the values in the fields instead of looking at the ID of the object, which is typically how classes in C# do equality unless you override the equals. And so we get A equals to A clone is true, and then A equals to B is false, and that is because A does equal to A clone, at least the values do, and B does not equal the same as A and A clone. The next thing to look at is immutability. So I've created this, object C, and we can see that direct mutation is not allowed. And the reason is that, this only under the hood has an init, which means you can set it on the constructor when you're actually creating this, but you cannot set it later. And so this is not allowed. And so what they've done instead is to provide an easy way to create new records from existing records. This is a very common pattern when we're dealing with immutable data types, is to have a way to create a new version of that thing with some properties changed. And so we can do that with the with keyword here. And so we basically are saying that we're going to take C with, and then we're adding in everything we want to do in our overrides here. And so when we print this out, we see that C person has first name okay, last name this is, and then C new last name has person, first name is equal to okay, and then last name equals to new name. So you can see that it actually did create a new version of this with the new last name we gave it. And then final thing to call out here while we're in the editor is that in order to print this stuff out, all I had to do was just pass in the record itself. And what we get with C# records is we actually get pretty printing out of the box. So it's just going to pretty print the object directly, so you don't have to build any kind of toString method yourself if you don't want to. Now that's it for the demo portion of this video, but I did want to make one final note, which is that records can inherit from other records. They do allow inheritance, but I would say that you probably shouldn't do that. In general, you should be favoring composition over inheritance, throughout your code base. But I think that's especially true when all we're doing is modeling data. Records are really supposed to be very thin data types that just model data and pass data around. And so if you're ever doing inheritance or something with this, you should really do a double take and probably even a triple take before you do that to make sure that there's not a better way to accomplish whatever it is you're doing, because that is a very weird pattern to be doing with records, I would say. And so you should probably be avoided unless there's absolutely no other way to do whatever it is you're doing. Next. So I generally prefer a separation of data and behavior, and records suit that purpose far better than classes in C#. Records are my first choice if I'm trying to model or pass data around, and I only reach for classes if there's some additional behavior I think would be useful to be attached to that data specifically. Typically there's not, so for most cases, records and functions do most of the work. And I do realize that this is kind of weird in C#. C# is a very object-oriented language. That's how it's been for the past, few decades whenever it was installed or created. But I think in general, classes are mostly good if you have, again, behavior that is directly associated with the data and operating on that data. But even then, in most cases, having pure functions that operate on any data you pass in is going to be more testable and composable overall. And records are starting to allow that kind of paradigm more in C#. Now, the full demo code is here in the blog post, everything that I showed you and ran. But if you want the full project files, you can join Hyminians, access to the full source code here on GitHub. By joining Hyminians, you get access to dozens of example projects, including this one, and you also support me in building future projects and tutorials. Now, if you like this post, you might also like F# like records and Python, talking about how F# does records and how it's kind of similar to the way that Python does it. Might also be interested in Python data class best practices. Data classes are basically Python's implementation of what C# records have, and a deeper dive into why I think records are so useful in general code bases. And finally, my 2025 programming language tier list, where I'm ranking things like F#, Golang, C#, Python, all against each other, and some of my reasons why some are so high and some are so low. So that's it for this video. Thanks for watching, and I'll see you in the next one.